guys, so we're going to start working towards wrapping up this chapter. We have 2 sections left, and today we're going to see what happens from area and perimeter of 2 shapes when we change dimensions. So the first thing we're going to do is we're going to do a little exploring. We want to describe the effect of each change on the area of the given figure. So we're going to revisit our area formulas. So we want to see what happens to the area of this parallelogram when we double the height. Okay, so the first thing we're going to do is we have our original. And of course we want to do base times height. So our height here is 9 and our base is 12. So when I do 9 times 12, I get 108 meters squared. Okay, now if I end up doubling the height, I end up changing that to 18 meters. Well, let's go see what happens when I have a doubled height. Now it's 18 times 12, which turns out to be 216 meters squared. So what happened when I doubled the height is that my area doubled. And that would be your answer, and this is going to be your evidence to support it. So if the height is doubled, the area doubled. So in this case, I changed one dimension. I did not change the base and the height, I just changed one of the dimensions, and that doubled the area. Okay, so let's check out this example. So the base length of the triangle with these vertices is multiplied by 1/2. Okay, so let's go ahead and do our original. So I'll just do O for original for the sake of time. And I want to do 1/2 base times height. My base is 5, my height is 4, so they're not making us do too much work here. And I end up getting 10 units squared for the area of the original. Now, if I multiply it by 1/2, I multiply my base by 1/2, I end up getting 1/2 times 5 over 2, or 2.5, however y'all want to think about it is fine, times my height. Okay, so based on what we saw here, when we doubled one dimension, our area doubled. Let's see what happens in this case. I end up getting 5 units squared. So when I changed one dimension and cut it in half, my area was cut in half. So let's see if we can see some patterns developing. So looking at example 2, we want to describe the effect of each change on the perimeter or circumference and the area of each given figure. Okay, so the base and the height of a rectangle with base 8 and height 3 are both multiplied by 5. Okay, so for my perimeter, for my original guy, all right, so we'll do O for original. 2 times 8 plus 2 times 3 is going to give me 16 plus 6, which is going to be 22 meters, okay? And then my area for my original, of course, is going to be my base times my height. So I end up doing 8 times 3, and I get 24 meters squared. Now, they're both multiplied, so let's see how that changes for our manipulated dimensions. So if they're both multiplied by 5, this is going to become 40, and this is going to become 15. So I have 2 times 40 plus 2 times 15, and that perimeter is going to be 110. So we'll notice that when I went from this to this, when they were both multiplied by 5, the perimeter was multiplied by 5. Let's see what happens with our area. So my area, base times height, I have 40 times 15, and I end up getting 600 meters squared. Well, I'll notice this is multiplied by 25, or 5 squared. So when I changed one dimension on the previous example, and we explored area, the area was multiplied by that value. However, when I changed both dimensions, the area was multiplied by that number squared. So that looks like a pattern that's developing to me. So let's look at this radius here and see what happens. The radius of circle A is multiplied by 1/3. Okay, so let's go ahead and let's deal with their circumference. The circumference is, of course, 2 pi times your radius. So this is my original guy. and I end up getting 18 inches. And then for my area, of course, pi r squared, so pi times 9 squared is going to give me 81 pi inches squared. I'm just going to leave it in terms of pi so I don't get bogged down in the decimals, okay? So now, if I take this guy and I multiply it by 1/3, of course I end up getting 3 inches. So let's see what happens. So my new circumference is going to be pi times 3, 2 pi times 3, there we go, which is going to be 6 pi inches, okay? So this was divided by 1/3, or multiplied by 1/3 divided by 3. And let's look at our area. Pi r squared, so pi times 3 squared is going to be 9 pi squared, 9 pi inches squared. This is divided by 9, okay, or multiplied by 1/9, which is the same. It fits our pattern. That's the same thing as 1/3 squared. Now, it's a little bit different here. If the radius or the side length of the square is changed, it changes it proportionally. So the reason being, you only have one dimension here. Here, you have 2 dimensions. You have a base and a height, or a base and a height, however you want to think about it. Here, I only have one dimension. My radius is what is a value. So that's why you only have one dimension to keep it proportionate when you're dealing with your circle. So this sums up what we've been exploring, guys. When you multiply all dimensions by 5, for example, in our previous example that we did on our previous slide, the perimeter or the circumference is going to be multiplied by 5. And the area is going to be multiplied by 5 squared, for example. Now, you guys can memorize this, or you guys can go through the explorations that we just went through, and it will shake out for you. Okay, there's no need to memorize this. You can just explore it, crunch the numbers, and then notice the pattern. So if we look at this, guys, this is going to have us work a little bit backwards. Think about the material a little bit differently. So your square has a side length of 5. Of course, all the sides are going to be congruent. If the area is tripled, what happens to the side length? Okay, so let's go through and see what we have here. So my side length here is 5. So my area is going to be 25 centimeters squared. Okay, now if the area is tripled, so that means that my area here is going to be 75 centimeters squared. I want to figure out what is my side length here. Okay, so let's go through and let's see. We'll call this S and S because again they're congruent. So I know that S squared is going to give me 75. Take the square root, solve by taking the square root. You don't have to worry about plus or minus because you're dealing with a real world situation. You end up getting root 75, the 5 breaks out of jail, and you get 5 root 3. So the question isn't asking me for the side length, it's saying what happens to the side length. So I'm starting with my side length of 5. What happened to make it 5 root 3? I just multiplied by root 3. One more example here, just so you guys can get the rhythm for it. A circle has a radius of 6 inches. The area is double, which happens to the circumference. Okay, so here's my circle. My radius is 6 inches. So let's go ahead and find our area of this guy. Pi r squared is going to give me 36 pi. And again, guys, keep it in terms of pi. Don't worry about him. You're just dealing with the numbers here. Okay, now if I double the area, and of course this is going to be inches squared, just to work nice and pretty. If I double the area, then of course I end up getting 72 pi inches squared. All right, I just multiplied this by 2, pi's coming along for the ride. It wants to know what happens to the circumference. Okay, so for my original guy here, my circumference is going to be 2 pi times 6, which is going to be 12 pi, and I basically inches, and I basically am examining how do I go from this to my new circumference. However, I need to figure out my radius is. So don't forget about what your formula is. We're solving for r, for my new circle. These guys go away, and again, I want to take the square root. The 9 breaks out of jail. Oh no, I need to simplify it even further. The 36 breaks out of jail, and I get 6 root 2 equals r. So my new radius is plus or minus 6 root 2, which is going to be 6 root 2. So that means that my circumference for my new guy is going to be 2 times pi, I'll just make that a weird looking pi, times 6 root 2, which is going to be 12 root 2 pi. So this is the circumference for my new guy, and this is the circumference for my old guy. What got multiplied? What got added in? I multiplied by root 2. So you're just kind of manipulating these different formulas in order to examine the relationship between them. So we'll go over this again in class tomorrow, guys, just to make sure we're crystal clear on what's happening. And then this is the homework that we'll be working on in class.